At this point, I've compiled all the information for the population of Los Angeles and Philadelphia every 10 years up until 2030. Haven't filled in the quantity of change or the percent of change columns yet, just because I wanted to show you really fast that Excel, because it operates in formulas if you input things correctly, makes doing mass calculations incredibly easy. For example, what is the change in population in terms of quantity? It's always what it is during this period, which would be cell B5 for right here, minus what it was before, B4. Well, if I use the fill handle, it'll just drag down those cell references one spot. So if I drag down one spot, the formula in this cell would be B6 minus B5, which is exactly what we want as the population change for Los Angeles. It's 467,928 people between 1940 and 1950. And I can just do that the whole entire way down. And it's going to calculate the change that we had every period for a decade for Los Angeles for that time period. Same thing's true with percentages. We always find the percentage, and you can see up here in the formula bar, as the change during the current period right here divided by what it was before the period started. So it was 21.72% in 1940. We got that by taking C5 and dividing it by B4. Down here I would just want to slide these down one spot. So C6 divided by B5, and if I use the fill handle, it indeed is going to change the formula to that. So I can fill handle this the whole way down too. Let's do the same thing for our numbers over here for Philadelphia. I'm just going to fill handle in this column, and I am going to fill in the change as well over here. So now we have the actual quantity of population change and the percentage of change for all of the periods for our two different cities that we are looking at. Back to the question, what is it asking us to do at this point in time? It says right here is whether any change, the first thing we should do is determine whether any change during the time frame should be considered an outlier. Let's start there. So firstly, we do have a line in here. We have 2030 for both cities. That's not an actual observed data point. It is a projection. This people, data is beautiful, are trying to make a projection about what the population in these cities will be in 2030. But since it's not an actual observed point of information, we don't want to use it in our calculations to determine if there's outliers. So I firstly am just going to go for these two areas right here. You can hold down Control to highlight different spots at a time. And I'm just going to change them to a color. It doesn't matter what it is, purple, just so I know not to grab those when I'm doing my calculations on accident. For outliers, I'm seeing a number right here, just my gut is telling me in Los Angeles, that change of over 100% they had between 1920 and 1930 seems like a lot. It's not in line with all of the other changes that we had here. So my gut tells me that that's an outlier. But we can figure this out mathematically by using the formula for determining outliers that we had. What is that formula? Well, for the upper outlier, it is going to be Q3, the third quartile, plus 1.5 times the interquartile range. Anything above the return we get for that should be considered an outlier. For the lower limit of outliers, it is Q1 minus 1.5 times the interquartile range. Anything below the result you get for that formula would be considered an outlier on the low end. So I'm going to need to figure this out, Q3, Q1, and my interquartile range. And I figure while I'm at it, why not just grab the median as well? So what are the data points that I want right here for LA? I want Q1, I want the median, I want Q3, I'm going to need the interquartile range to determine my outliers, and then I'm going to need the upper and lower limits for what is the cutoff point for something's an outlier or it's not. To find the first quartile, I can use the quartile function. So if I go to insert function and I type in quartile, I get a bunch of returns. I want the inclusive one, so quartile.inc. You could use the percentile function if you wanted to. You always have to put in 25% for the first quartile, but for this one right here, it gives you the same functions, but you get to type in the actual number for the quartile, as you'll see. Take the array of numbers you want to look over. I want just the observed data point, so I'm not touching that 2030 line, just all of the stuff that actually has occurred, the years that have passed in time up until this point. And the quartile I want, as you can see down here, is the first quartile, which I will signify with a 1. So the first quartile of that data is 6.35%. For the median, I can use the median function. So let me go grab that guy. And I want the median of the actual observed points we have, again, not 2030. I'm going to hit OK. And the median rate of change in Los Angeles over that 100-year period is that every 10 years, population increases by about 15.3%. For the third quartile, we are going to want to use the quartile function one more time. So I'm going to grab my range, and my quartile that I want here is the third quartile. And by the way, if you're getting returns not in percentages over here, it's looking like a bunch of decimals, you can always change it to percentage. Like say it's just looking like, you know, I don't know, let's put it in general format. Maybe it's looking like that and you want to change it to a percentage. Just click the percentage button up here, like we did before, to change it over a couple of decimal places. There we go. So the third quartile, or 75th percentile of the data, means that 75% of the points that we have in here were less than set 24.49%. What is our interquartile range? It's always the same formula, Q3 minus Q1. And that is 18.13%. So the middle 50% of observations that we have are within roughly 18% of each other. Now let's use these formulas over here to determine what our cutoff points are for outliers for Los Angeles. For the upper, it's Q3, click that, plus 1.5 times the interquartile range, which is 18.13%. And we get 51.68. Any change that we have that's above 51.68% in a 10-year period should be considered an outlier and not representative of the rest of the information. We definitely got one of those. So my gut feeling is checking out right here. This change in 1930 is an absolute outlier. It's a huge rate of change. Nothing else looks like it. Using that could really mess up our information. I'm going to say that's bad. And the style formula changes to bad if I want to, so I know not to put that into future calculations. That is most definitely going to be an outlier. What about the lower end? Well, we'll use the lower outlier formula, which is Q1 minus 1.5 times the IQR, which I don't have to type in, I can click. There we go. And it is negative 20%. None of my information is at a rate of decline in this case that is lower than that. So we don't have any lower outliers for Los Angeles. Let's get that same information for Philadelphia. I'm just going to use Control C and Control V again to bring down the things that I want, and I can use the same formula. So for the first quartile, I'm going to use quartile.inc. The array that I want is all the actual observed points for Philly, so from 1930 down to 2020. The quartile that I'm looking for is the first quartile right here. So I type in 1, I hit OK, and the first quartile for Philadelphia is negative 4.01%. For the median, I want the median function. Highlight all of my observed data points again, hit OK, and the median is a decline of 1.82% during that time frame. For the third quartile that we have here, I'm going to use the quartile inclusive function one more time. I'm going to hit OK, highlight that same set of information, and my quartile is 3. So the third quartile for Philadelphia is 3.29% increase. I want the IQR, which is just the difference between Q3 minus Q1, and that is 7.31%. And now I could use these formulas to identify if any of our Philadelphia information should be considered an outlier. The upper bound is Q3 plus 1.5 times the IQR, which is 7.31%, 14.25%. Any 10-year period where Philadelphia's population increased above 14.25% would be considered an outlier. But none of these Johns are any of that, so we don't have to discard any information as an upper outlier. What about lower? Well, Q1 minus 1.5 times the interquartile range of 7.31% comes out to be negative 14.97%. So anytime there was a decline, there was a lower number than this, it would be considered a lower outlier. And while the 1980 decline is indeed close, it's still with less than, it's not within that range, it's not below 14.97% of decline. So we don't discard anything. Philadelphia has 0 outliers. So now that we've determined that LA has an outlier, for our rest of our calculations, I'm going to use all of the non-outlier points that we have, whereas with Philly, we get to use the whole entire range. And discarding this is going to make a pretty significant change. Let's do the mean over here for Los Angeles. I can just use average for that. If I keep the outlier in there on purpose, it's telling me the mean average rate of change that Philadelphia or that Los Angeles had during the period is just over 24%. Let me delete these formulas out over here. We're going to make sure I don't get my information screwed around. Merge and center these guys, and we'll call that with the outlier in. What happens without the outlier? What happens when we throw out that one bad rate of change? Let's keep my numbers lined up over here. Our mean is going to be equal to the average of all the numbers that don't have the outlier in it, and that comes up to 14.5%. Huge difference. Including that outlier makes the average rate of change in Los Angeles look like it's 10% higher than it probably actually should be. So we definitely want to get rid of that outlier. We now have to redo all of our information over again, and I'll even be thorough and see if there's any outliers left in the set over here. Now that we're choosing to get rid of 1930, so what's the quartile function that we have right now? Let's go to our quartile inclusive function. We want it for the non-outlier range in the first quartile, and it comes out to 5.96%. For the median, get the median function one more time. Again, now just using only the non-outlier observable data points. And the median rate of change for Los Angeles in that time frame, after we discard the outlier, is down to 13.41%. For the third quartile, to grab those same points, 1940 through 2020. I want the third quartile, so I'm going to type in 3 for quart. Our interquartile range is always Q3 minus Q1. And we can see, just looking at these numbers, they're all lower. They're getting rid of that outlier greatly reduced the variance in the results that we have for Los Angeles. I guess to be thorough, let's do our formulas one more time to make sure there's something in our data set now that still shouldn't be considered an outlier. Q3 plus 1.5 times the interquartile range is 45.35%. Yep, none of those numbers are above that, so we're good there. Here you would have Q1 minus 1.5 times the interquartile range, which is 15.75%. And that is a 17.67% decrease. Los Angeles never decreased during this time frame, so we definitely don't have an outlier there. So our information is pretty good to go for LA. And because we didn't have any outliers over here in Philadelphia's set, we don't have to mess around with removing anything from our information. Let's find out what the mean is for Philadelphia. That is going to be the average of all of our observed points, not discarding anything because we don't have any outliers. And that is a decrease of 1.19% during that 100-year period. So back to our question over here, it is asking us to do a bunch of things. We got to find what the mean and median percent of change is for each city over that time frame. We already have that, we just did that. And the next part, we have to make some kind of projection based upon the information we calculated on what the population would be in 2030 according to our data. Not what the video has, but what we have. And we're going to cover that in the next part of this video.